this is a sound wave. Now I had drawn the wave on water with like this or on. So we have got how many waves? We can think of a sound wave. We can think of EM waves. We can think of water waves. We can think of waves on a string, waves on a string, like on a rope. We can think of seismic waves. So there are something called matter waves, but that is not in course right now. So seismic waves, water waves, wave on a string, EM waves, sound waves. There's a slight difference. Like here, EM waves is a transverse wave. That means the particles vibrate up and down. Water waves on the surface, if you find water on the surface, it's transverse. But inside water, like if there's an explosion inside water, it comes out in something called rarefactions and and this rarefactions and compressions. What happens is the particles which are evenly spaced initially, as the wave passes, some get compressed, some come close together, and some get there's some space created. That's called lower pressure rarefactions. So it's something like this. Some part will the particle vibrates along the direction of the wave. Like mean if the wave is just an energy is going forward, the particles are also vibrating in the same direction. Now the particles are not moving forward; they will remain where they are, but the energy moves forward. So even here, if the vibration is up and down, the particles vibrate, don't move. The particles go up and down, but the energy moves forward. The wave moves forward. The particles move up and down. So here also the only difference is particles are moving along the direction. So they are causing compressions, higher pressure, and expansions, lower pressure. And this is how sound moves. So now sound is of two types. Something which you can hear, which is about 20 to 20,000 hertz. That's called audible sound. It's audible. And beyond 20,000 is called ultrasound. Now, there's a difference between they use these ultrasound waves to investigate in medical sciences inside the body because X-rays are harmful, especially with small babies. So they don't use X-rays. So they use ultrasounds. Ultrasound is also a compression and a rarefaction. The only difference is it is at a very high frequency. And so if they're high frequency, they're high energy, they can penetrate the body. And what happens is they penetrate the body and they do two things. Either they will go and hit an interface and get reflected, like if there is a bone or if there is a bone or a skin or a fat interface, they will go hit and they will some part will be transmitted, some part of the incident wave, some part will be transmitted and some part will be reflected. Now that depends on the density and the speed of sound in that medium. But what they do is they can judge that from the all this and the image, they will produce a scan by the reflection and you see what's inside the body. So it's like using high energy sound waves to enter the body. Now these are not X-rays. X-rays can also penetrate, but they are not they are harmful for the baby. So for normal humans, which are they do, but not for babies. So that's they use this ultrasound, and this is the concept. The so it's like something coming back, and when it comes back, it's like an echo or a reflection, and the time it takes, they can calculate the distances, and that is what they do in other things also, like in uh, in finding the depth of submarines, where the submarine is, where the depth of the ocean. They send some waves, and the waves are reflected back here. Like they send a wave. It's the same thing as an ultrasound inside the human body. the same concept. They send this thing, and the wave hits and comes back like in an ultrasound. And from the time it takes, and they can calculate, they know the speed of the wave, they can get the time, and then they get the distance. And that means this is the distance from here to here. So the depth is half of that. So half of 140 is 70. So this way they can calculate the depth. So this can only be done with ultrasounds. Ultrasounds we can't hear. Bats can hear, because our ear is not is this reflected, the pulse is sent, the reflected wave comes, and you can see the time it is elapsed, and then you can get the distance and the depth or the part of the body, different layers inside the body, and the signals are processed. You understood how we are using sound waves to find depths, especially ultrasound waves.